Hey, hi. Today we are going to solve minimum swap to arrange a binary grid. I have created one page for you where you can see visual representation of how swaps are happening. Okay, so instead of here explaining you all the stuff, I'll take you to that page. I'll explain you problem statement, what we need to do. We'll see couple of examples, how we can solve that out, and finally we are going to code it out. Even the thing is I have already coded, but I'll let you know how to do that problem at that moment. Okay, so let's switch back to the our page which I have created with the help of generative AI, and that's the page. Lead code medium question, and the question number is here, and question topic is here. Now, what the problem says? Given an n cross n binary grid, in one operation you can swap any two adjacent rows, like row 1, row 2, like that. Okay. Now, what we need to do? Return the minimum swap needed so that the upper left triangle of the grid is all 0 or -1 if impossible. So what it is saying? It is saying like this one is upper section of the grid, right? And these are filled with 0. That is what we wanted. If that is not possible, means even after swapping rows, if that is not possible, then we are going to return -1. So that is what our requirement. Now if you see in first row we have three zeros and we wanted three zeros, right? So it is perfectly aligned. And next row we wanted 2 0, and here also it is perfectly aligned, no swap required. And same with the R2, means if we start from 0, so 0th is aligned, 1 is aligned, row 2 is also aligned, and row 3 is also aligned. So this is something which we wanted. Now let me take you to some example and then we'll solve this. Okay, so here let's go to example and the case where no swap is required, because this section you see is upper section and it is already filled with zeros, right? So I'll just try to let you know what we are going to do. The thing is, in this situation, the swap is 0. Current row is not calculated yet. 0 needed is not calculated yet. What you need to do first, you need to calculate how many zeros are before encountering any one in any of the row, right? Let's say we are talking about 0th row. So we need to count from backward from the end, and that will be first 0, second 0, and third 0. So we have three zeros. If we talk about row 1, we have 1 0, two zeros, and next is 1. So we have just two zeros, right? And same goes with row 2. We have just 1 0, right? If you see, we just calculated this. Means what is the zero count from right side in row 0 is 3. Similarly, in next row is 2, next row is 1, and suppose that in last row we have zero zeros which are uh, at the end, right? Trailing zeros. So next what you need to do, you need to pick first row and you need to check whether swapping is required or not, right? So what do you think? Swapping is required? No, right? So we are not going to do anything. No swipe required. Next, we are going to take next row and check whether the swapping is required for that row or not. It is required? No, right? So we don't have to swap. Same thing with the second row, no swap required. Move to third row. Is swapping required for third row? No, right? We don't have to do anything. Fourth row means if we start from 0, it will be third row. So in this row, swapping required? No. All set, right? So what will be the minimum number of swapping required? 0, right? Now, in this case, if you see how many trailing zeros? 0. How many trailing zeros here? 2. How many trailing zeros in this row? 3. And how many trailing zeros in row 3 is 1. Now, if you see, if we place all these zeros here, then our 0th row will be satisfied, right? So how many swaps will be required? We'll be swapping this row 0 with row 1, row 1 with row 2, right? Or you can say the row 2 will be swapped with row 1 first, and then row 1 will be swapped with 0. So this particular row will be swapped here, and this row again swapped here. So the 0th row will be at its position, required position, right? So let's run this. Means we have calculated trailing zeros. What next? We need to check for the 0th row, right? 0th row. Now what we need to do, we need to find a row which will be fulfilling the condition. That will be second row, right? Means we need to swap this row 2 till 0. Now what you need to do, you need to swap this two row first, means row 2 and row 1, that will be swapped in one step, right? Now next is we swapped this as well, means from here to here we have swapped, two swaps required, and this one is fulfilled now. Now what we need to do, we need to take care for row 1, right? For row 1, this will, row 2 can satisfy the condition, right? Means all zeros will be in this two place, right? So what we need to do, we need to swap this two particular rows, right? So let's do that. Swapped. Now row 1 is also aligned. What next? Now it's time for row 2. And if you see row 2 and row 3 have one zeros which will be placed here, and the upper triangle will be satisfied. So for row 2, what we need to do, we need one more swap, right? And swap will be between these two rows, and it's got swapped. So how many swap till now we have made? That is 4 swap. And swaps history, you can see which rows are getting swapped, right? Now finally for the last row, is swapping required? No swap required. Means our algorithm will complete. Means this is how we are going to solve, and the minimum number of swaps required will be 4, right? So this is what we need to do. And there is one more case where it is impossible to create that. Why it is impossible? Now here we want two zeros for the first row. We first calculated trailing zeros. Now for the first row, is there any row with two trailing zeros? We need to find that. No, that is not in our list. So in that case, we need to return -1, right? So here are code for it. What we have done, before going to code, let me explain you the our two-phase approach. What we have done, we have counted trailing zeros per row, right? Now for each row, find the eligible j, means which other row which is greater than I can be swapped, right? That we need to find. Next is we need to use the technique of bubble sorting, and basically you need to bubble row j up to position I, means you need to just swap, like I have already explained you in this example, like you need to swap this second row with the row 0. So what you'll do, you'll swap row 0 and row 1 first, and the row 2 will be shifted to row 1. Now you will be shifting row 2 to row 0. With that way you'll be solving, right? So we just have to do that and accumulate the swap count. That's it. That the same thing is written here with conditions and all. And let me go to the code and explain you. Here some codes are highlighted because these are important point. This is JavaScript code, but what I'll do is I'll explain Python code. And here if you see, the thing is, what we have done, we have created an array of how many zeros, trailing zeros per row we have, right? Initially we initialized it as 0 per row. Next, what we have done, for each row we have calculated trailing zeros. If we are getting, and means uh, as we are encountering zeros, we are counting +1. Example, in this case, here if you see, 0 count as 1, here 0 count is 2, here 0 count is 3. Now we encountered 1, we'll be breaking at that point. Else we were just adding up or increasing the count from initial 0 to 1, 2, 3, like that, right? Now once we have that array, what we are going to do? We are going to use the technique of bubble sort a bit here. Now, if you see, for each row we need to perform whether that row is its correct position or not, right? So how you can do that, you need to first calculate how many zeros required in that particular row, means number of trailing zeros which are required. What you need to do, you need to take a pointer from that particular row and check whether that row can fulfill or not. If that row can fulfill, you don't have to perform swap and all, you can jump to next row. But if that is not the case, means you need to find another row which is fulfilling that condition. Scan the next rows and get for the possible rows. Once you have that possible row, you need to check if you crossed the last row. If you cross the last row, means you didn't actually able to find a row which can be swept. So in that case, we are going to return -1. But if that is not the case, means we found a row through to which we can swap, then in that case, you just have to keep swapping two adjacent row, and you need to basically subtract j by 1 and swap increase swap by 1, right? You just need to copy this code, and let me try running it here if this will work or not. Okay, so yeah, this is the pretty much that code, and let me try running it. Yeah, that is the code and it's running. Let me submit it. I have submitted the same code previously, so it will work fine, right? Yeah, so that is the code. And yeah, one last thing I forgot to mention, that is related to time complexity and space complexity. What will be the time complexity? We are iterating the whole array one time here, and in between we are iterating one more n times here, right? Means this for loop can run n time, and this will be running for order of n time. So if you multiply that, it will be order of n square. So number of swap pass will take actually n square. And here if you see, when counting trailing zeros, you used 2 for loop, and that also used order of n square time complexity. If we talk about space complexity, we used just a list that will be of size n, so space complexity will be order of n. So that is pretty much for this video. See you next. I'll try to simulate something like this for the next code as well, so that you can understand easily. And that is pretty much for this code. So this video. That's it. Thank you so much. Bye bye.